Hi, everyone. Thanks for being here. Thanks for being with us for the whole week. Hopefully, you've got a bunch of interesting things to think about and a bunch of interesting things to learn and inspiration to do something awesome yourself if you're not already. And if you're not already or looking for something to contribute to and play around with the ideas that you encountered this week, hopefully what I'm about to present will give you an avenue to do that. So I've done the first part of my presentation is similar to what we've done before, what you might have seen before, but I'm gonna recap quickly so that those who are less familiar with Sherpa get a sense of what is going on. So to start, the idea of what we're working on is essentially creating an oracle that collaborates with humans. So the purpose of Sherpa is not to be an autonomous agent without any contributions from humans, but rather an oracle that essentially coordinates and orchestrates work, knowledge-intensive work that a lot of humans might do as they collaborate and build together, and help that process to become much more efficient and effective. And the topic of knowledge management came up a few times during the day, and that's essentially what this system is all about. To talk about knowledge management on a very high level, essentially the idea is how can we use externalized pieces of knowledge like documentation, like scientific papers, GitHub repos, as well as expertise of humans involved in a project most effectively so that we can get the objectives that we have much faster, better, cheaper, etc. So let's get into it. I previously introduced the concept of KnowledgeOps. We talked about this quite a bit, and I will recap it quickly. But I have a new definition for what I like to call KnowledgeOps, which is essentially scenarios where you use LLMs or similar technologies to create multi-agent, multiplayer information-seeking systems. And I will elaborate what this is as we go. But agents refer to machine agents, and players refer to humans. So essentially, what I like to emphasize is the fact that the systems we are creating, and in my opinion, the systems for the majority of knowledge-intensive workflows require a very close collaboration of humans and machines, and otherwise they will not be as effective. So let's get into KnowledgeOps. KnowledgeOps involves with handling assets. And as I said, assets could be things like data, code, tool, documentation, or it could be involved with human processes like communication, collaboration, and project management. So essentially, KnowledgeOps is not, generally speaking, knowledge management is not necessarily only about handling artifacts, but it is about artifacts as well as processes. So how close are we to being able to use large language models for very complex knowledge-intensive work? This is an interesting graph that I found recently. It's from 2018. I believe this is from Gardner, but Tim Elliott, link is down here, talked about it, used it. That's where I got the graph from. So essentially it talks about different types of quote-unquote AI, artificial intelligence, analytics, whatever you want to call it, and how different entities and organizations are adopting it. The very first bit, to the left is essentially using data to get insight, so sort of describing the past. So this is what we sometimes call descriptive analytics. So the type of technologies and approaches we use to just understand what happened in the past. There's another type of AI that a lot of us got involved in, things like predictive analytics, which is predicting when and what will happen. Or prescriptive analytics, which is what action should be taken for a desired outcome to happen. I guess a canonical example of that is autonomous driving, where AI is deciding how to take action so that we don't run into accidents. And the more sophisticated version of this is what we called autonomous systems. But what is important is that most of the predictive, prescriptive, and autonomous systems are extremely specialized for a specific type of tasks. And normally going from the left to the right in this graph requires a non-trivial amount of progress and improvement in data quality, infrastructure, expertise, etc. So the fact that you can dashboard things doesn't necessarily mean that you can build machines that do complex things. And Gartner paper article talked about this chasm between these two that is very difficult for a lot of businesses to cross. But if you do, you unlock a lot of more interesting things. So why do I bring this up? Because you're in 2023, 5 years later, and in the past 5 years, or the majority of the past decade, the conversation has moved from where is this chasm? How can you cross it? To this new chasm, I think that I call the narrow AI chasm. And the idea of it is that, as I said, like the majority of these functionalities are available only for very specialized type of activities, very specialized tasks. Therefore, like they could be significantly good at, they could be very good at doing something very, very specific and narrow, but not necessarily more complex things. And one of the things that I think is not very trivial for a lot of people is the fact that LLMs are the very first time, or generative AI in general, is the very first time that we have started to cross this chasm to more general purpose types of technologies rather than very specialized technologies that we had. And the reason that I'm making this claim, and I hopefully am not alone in making this claim, is that large language models, it is true that they are language models, and therefore the majority of their focus is on language skills. But formal language or coding is also a significant part of their training, and therefore their abilities, which means that they're good at using tools, as long as tools are controlled programmatically, right? So therefore, they immediately gives us the ability to communicate with them through natural language. With them, I mean with systems, with machines, through natural language and its interface with formal language, therefore coding. And large language models also have some superficial reasoning skills, mostly because there are a lot of content on the internet that says, if you were to solve these problems, here are the steps of how you can do it. And therefore, language models have picked up those types of, process of problem solving, etc. You obviously, we've heard that a few times today, but, if you've been also looking at this space, there are some other non-trivial things that you can do to prime them to do this better, like chain of thought reasoning, etc. But essentially, the interesting, I think, observation is that for the first time, we have a tool that is helping us to go from narrow AI to a broader AI. I was presenting this last week in Banff, and obviously a question that came up was, is this AGI? And that's a question that is open and we can discuss it. I don't think it is. I think it is the first time that we are just peeking across the chasm and looking at what's on the other side, and there's still a long way to go. But from a functional point of view, we have these capabilities. So the question is, what are the interesting things we can do with this? So the example that I gave in my previous talks, and you might have seen this already, was the ideal scenario, the holy grail, is that we can create machines that enable us to do research as we are walking on the street, right? Or if you're jogging outside, so that you can just pull up your phone and say, hey, Sherpa, how can I solve this specific research question I have? And then these language models will use their natural language capabilities to interpret your question, generate a set of tasks, prioritize these tasks using their reasoning skills, then use their tool skill the tool usage skills to execute these tasks, use their reasoning skills to reflect on what has happened so far, and then their language skills to interact with you, get your feedback, ask follow-up questions and things like that, and do this iteration a number of times until you reach an objective that you have that might be an answer to your question, or might be writing a report with some code and all of those good things, right? So without necessarily sitting on a laptop and typing, you could get machines to do interesting things for you, like what I'm showing. Previously, I've been presenting this project as an LLM live book, essentially a book that writes itself and you can talk to it. But since last time, with the community that is involved in this open source project, we decided that this is actually much more than just a book, and we are actually building something that represents the idea that I showed in the previous slide, and therefore we have to rebrand the project and talk about it differently. So going forward, essentially the structure of the project is that we are releasing a Python package. We call it Sherpa AI. The tagline of this Python package is human in the loop, multi-agent workflow augmentation framework. So the idea of it is that it uses large language models along with other things to help you do things within your workflow. And we are especially and specifically interested in not the types of workflows that are very admin task heavy. Like the goal of Sherpa AI is not necessarily enabling you to schedule a bunch of meetings and handle a bunch of conversations, etc., but more specifically knowledge-intensive workflows, like processes where you have to do research, synthesize that research, and present it to a customer, for example, or set it up as a proposal for a grant that you're writing, etc., etc. Right? So essentially, what this Python package will do is to provide a series of data connectors. These data connectors can go to different tools like Notion, where your notes might live, or it might go to some public resources. There might be some custom tools that we build to aggregate information that comes from these sources. But we might also use third-party tools like Google Search to empower Sherpa to get up-to-date information as well as domain knowledge or other types of data that is necessary for it, aggregate it, and then provide also connectors to different types of tools like Slack, as I showed at the beginning, where the user can interact with Sherpa and its workflow automation capabilities, augmentation capabilities, without leaving your tool stack. So essentially, whatever you're already working, our ambition is to create an integration. Could be Slack, could be Teams, Google Docs, could be WhatsApp, whatever you're working to do, whatever you're using to do your work, we want to eventually have a connector to, so that this core Python capability is generalized into a lot of different tools that you're using, so that you don't have to leave your workflow to do your knowledge handling. So I think I showed this before, but one of the things that I usually like to emphasize about Sherpa and the fact and the philosophy of the name is that Sherpa the inspiration for the name Sherpa comes from shepherds in Tibet that help groups of people to climb the Mount Everest. And what I like to say as a joke, but I think that's very important nuance, is that Sherpas never climb the mountain on your behalf. Their goal is to help and coordinate a bunch of people to do that very complex task. So, and that's exactly the vision that we have for Sherpa, essentially for it to be a co-pilot, a tool that sits around within the process within the workflow that you usually take, and help you achieve your goals faster and better and cheaper. So how does it work behind the scenes? This is super high level, but let's say John, the person, asks a question, provides an objective to the system. And then there is a large language model agent. Let's call it an oracle. This oracle has the task of interpreting and interacting with the human agents, with humans. And based on that objective, it can come up with a plan for solving that problem. Like it could be a question, for example, then Oracle can say something like, I need to look up information from Notion, or I need to do a Google search, etc. So it comes up with a plan for how this problem can be solved, and commits the plan to a shared workspace. This is sort of a working memory, if you wish. And then another agent, let's call it a critic, can come in and say, well, these parts of your plan is stupid. You should change these. You should provide more detail, etc. And again, like all of this, conversation is happening in public in a workspace. So the human and all of the other agents have access to this information if they need to. Eventually, this debate is going to end, and the Oracle and critic are going to come to an agreement about how the problem should be solved. And then there are other agents potentially in the system, like a researcher that has access to lab notes and research papers and search engine and such. So it can provide a bunch of details about, it can handle the tasks that require research. There could be another agent called an analyzer that is capable of data handling. So it can call different types of models. It can, fetch a bunch of data, analyze them, etc. But all of these will provide their information back to the workspace that all of the agents have access to. And the critic, in some cases, could also use evaluation sets and test cases to check the information that is provided to the workspace to ensure that we are getting closer to our objective. But one of the very important things is that Oracle, the purpose of the system is not to be completely autonomous. As I said, the purpose of it is to enable humans to work more effectively with each other. So the Oracle might also sometimes choose to tag other humans involved in the project based on the expertise they have and say, hey, Jane, here's a task that you can do. And that task could be a rephrased version of what John asked initially, adapted specifically for the expertise that Jane has, right? So that facilitation of conversation and project management is a very important task that the Oracle is doing within the context of all of the actions that all the other agents are taking. So essentially, this becomes that multi-agent, multiplayer scenario that I described a little earlier. And we believe that for knowledge-intensive type of use cases, this is a much more reliable and robust way to ensure that the system doesn't fall into loops and provide a bunch of hallucinative information. Like there are a lot of opportunities for humans to control the behavior of the system and ensure that the outcome is reliable and robust and usable. So as I said, this is an open source project. A lot of awesome folks are involved in it. As you can see here, you are all welcome to join as well. There is no shortage of things that we can do in this project. So you can come in with your ideas. You don't necessarily even have to be technical. As I said, this project is about creating a thinking companion. So if you're a product person, if you're an entrepreneur, if you want to bring in some design ideas, some, even things as simple as helping us with documentation and writing white papers and articles and anything like that, that's completely fair. If you're a sophisticated coder, engineer, infrastructure platform, you can definitely use your skill set. If you're just starting to learn, how to play around with LLMs, we can still, use your expertise and, give you tasks that you can contribute. So hopefully, some of your beautiful faces will be added to this slide next time that we come up. I'm sure there are more people who are contributing and my garbage memory has missed them. So if that has happened, if that's you, I apologize. But I promise not to forget putting your face here if you join us for the next batch of work that we're going to do. To give you a sense of what we're going to work on next. So last time we talked about providing a verbose function for how Sherpa reasons. that's already available. Like if on a Slack you say at Sherpa, ask a question, and then write -verbose, it will provide the thought process essentially to you. We want that to be the default behavior at some point, but at the moment it is available through a flag. So play around with that if you want. Currently, what we're working on is primarily things that you see in the middle. We are also submitting this as a research assistant project to a NASA competition. So what we're hoping to show there is the impact of the multiplayer aspect, show that we can achieve self-consistency. And independently, a project that actually a few of the folks that are on the call are working on is to add a Hugging Face tool so that Sherpa gets better at answering questions about different types of machine learning models. And, we could always accommodate other types of ideas that you want to bring to the table with some discussion. They're also proactively working on improving our onboarding process by creating a checklist, more video tutorials, and even a botting system where new folks that join the project can essentially partner up with those who've been around for a while and get onboarded faster and more efficiently. So if you're excited about any of these, please reach out or just check the Sherpa Dev channel on Slack. And we can set you up to contribute. We meet every week and discuss things. So, it should be a pretty, hopefully, painless process. Obviously, you have to do some work, but as we make the onboarding better, but, hopefully we can get you onboarded as quickly as possible.
Yeah, so basically, I will not spend a lot of time on this. So the thing I want to introduce is 2 articles that help you to set up Sherpa locally. So the first article is basically tells you how you can basically run Sherpa with one line of code if you have Docker installed in your system. You can also run it with a Python virtual environment. So this requires some configuration, but hopefully it will not spend, you will not need to spend a lot of time in order to get it running. Of course, this is to for you to use Sherpa as a tool. You can also use Sherpa as a library. For that, you can actually just pip install Sherpa AI, and then it's already published on the PyPI index. So once you have the Sherpa running, you can follow the guide before it, which is if you want to connect Sherpa with your Slack app. So if you can just follow this guide, and then you will be able to have a Sherpa tool, Sherpa bot kind of thing in your own workspace, just like the one you can say in the Sherpa Dev channel or in the technical question channel of the Slack channel that we have. Yeah, so finally, if you're interested in integrate with some vector database, we preloaded a lot of large language model text into a vector database, which is described here. It contains a lot of things such as MetaGPT, LangChain, and all those documentations. So if you follow this guide, you can set up the vector database and connect it with Sherpa, and you can ask questions about LangChain and MetaGPT and all those things. And you can also use this guide to basically load your own data, no matter if it's your nodes or Notion nodes or Markdown nodes or anything. You can basically ask connect it with Sherpa, and Sherpa can help you to discover the knowledge for you.